The task in this first question is to find the orthocenter of this triangle using our algebraic processes. Vertices at 3, 1, 1, 2, 4, -2. Now the worksheet presented this way and asks you to focus on point A and then find the slope, the line as opposite A. Okay, so if I focus on A here, um, obviously BC is opposite it. Okay, so the first thing is asking you to find the slope of BC. The reason we're doing that is because our goal in this whole process, and underneath number 1 here, is to find the equation of the line that passes through A but is perpendicular to BC. So we're trying to find the equation of that line right there, which in y equals mx plus b form is what? It's 3/4 x minus 5/4. Okay, so that's what we're going to try to figure out here as we go through this process. But the first thing in doing that, the first thing coming up with the equation of that black line, is to first figure out the slope of the line that is perpendicular to it. Okay, so BC is the side of the triangle we're interested in. Find its slope, and then if we find the opposite side reciprocal, we then know the slope of that black line. So that's what we're doing. Here are our slope formulas, and then ultimately the point slope formula to find the equation of the line. I want to find the slope of, like I said, BC. So I'm going to use these 2 points. And I'm just going to do y2 minus y1 over x2 minus x1. So I go 2 minus -2, 2 minus -2 over 1 minus 4. Okay, so it gives me 4 over -3. So now the opposite sign reciprocal would be 3 over 4. Okay, and that's then the slope of the black line in GeoGebra that I was showing you. That's the slope of the altitude. Now we also know that that altitude, okay, so the slope of that black line is going to be 3 over 4. But we also know that black line goes through point A. So point A is going to be the y1 and x1 that we use inside this formula here. So we're going to go y minus y1, so that's the y coordinate from A, so it's 1, is equal to slope, so our slope is 3/4, x minus x1, x1 being the x coordinate from point A, so minus 3. That's going to give me y minus 1 is equal to 3/4 x minus 9/4. Add 1 to both sides, so it ends up giving me y is equal to 3/4 x minus 9/4. Adding 1 to both sides, I'm just going to rewrite it as 4/4. When I just combine those terms, I'm going to get y equals 3/4 x minus 5/4. And if we look back to what that equation was, y equals mx plus b form, 3/4 x is 0.75, 5/4 is 1.25. So that's the equation of that black line. Now parts 2 and 3 are going to do the exact same process, but point 2 says first concentrate on point B, and then find the line that goes from B perpendicular to AC, so it's going to be that line right there. And in this situation, what we actually have to do graphically to get this to happen is we need to extend that distance CA so that it from B we can actually be perpendicular. Okay, so it happens outside the triangle. That tells me right now this is an obtuse triangle. So we're going to do that. So we're going to find the slope of AC. So find the slope of A to C. So again, it's going to be, do everything here in green. We're going to go with 1 minus -2. So 1 minus -2 all over 3 minus 4. So that's going to give me 3 up top, -1 on the bottom. So then the slope of my altitude is going to be 1/3. Now I'm going to use, I know that this is going to go through B. Okay, so I'm going to go y minus y1 now, being the coordinate from that. So y minus 2 is equal to 1/3. Now x minus 1. Do my distributing. So y minus 2 is equal to 1/3 x minus 1/3. I'll add 2 to both sides. 1/3 x minus 1/3 Now 2 with the denominator 3 is actually 6/3. So this gives me y equals 1/3 x minus, or sorry, plus 5/3. So we'll see if that's the equation then that GeoGebra was giving for that line. Look at that line right there, y equals mx plus b, 1/3 x, and then that's 5/3. So we do have the appropriate information for that one. And now we're going to do the exact same thing for this third line. So we're going to focus on C. I'm going to focus on C and try to find the line that is perpendicular from C to AB. In order to do that, the first thing I need to realize is that we ultimately need to extend AB so that over here they will be perpendicular. I'm trying to find the slope then of that line right there. Well, first you got to find the slope of AB. So A to B coming up here, we're going to go 1 minus 2, so it gives me -1 up top, and then 3 minus 1, so it gives me 2 on the bottom. So -1 over 2 is the slope of A to B. Okay. The next thing I want to do is figure out the slope of any line that would be perpendicular to that, so it would be the opposite side reciprocal, so it's going to be 2. And now I need to understand that point C is 4, -2, so I'm going to write this here. C was 4, -2. So writing the equation, then I'm going to go y minus y1 is equal to m times x minus x1, but now y1 and x1 come from C. So we'll go y minus -2 is equal to 2 times x minus 4. So it gives me y plus 2 is equal to 2x minus 8. I'll move the positive 2 over to solve for y, and I get y, right up here, y equals 2x minus 10. If we look then here at this line right here, we do get y equals 2x minus 10. So those 3 points, so those 3 lines, that one, and that one, okay? Those blue lines are all considered altitudes, okay, because they go from a point perpendicular to the line containing the opposite side. They go from a vertex perpendicular to the line containing the opposite side. They're concurrent right there, which looks at like the point 7, 4. So we should be able to find that number 7, 4, or that ordered pair 7, 4, using 2 of those 3 equations. Okay, so that red one, that green one, and the black one. Okay, doesn't really matter which 2 you're going to use. I'm just for convenience sake, I'm going to use the green one and this black one. So I'll use 1/3 x plus 5/3. All right, so those are my 2 equations. Now, if these two things provide lines, if these 2 things are equal, then their y values are the same. Okay, and then the y values are produced by having essentially the same exact x values. So we should be able to say that those 2 things are equal when these 2 y's are equal. So we'll take 2x minus 10 equal to 1/3 x plus 5/3. I will get rid of these fractions by multiplying everything by 3. So we get 6x minus 30 is equal to x plus 5. Remove x from both sides, so we get 5x minus 30 is equal to 5. Add 30 to both sides. 5x is equal to 35. X then becomes 7. Now, if x is 7, I should be able to plug that value back into any one of the original equations that incorporates x and y and find my y value. Well, I'm going to plug it in to that equation right there. And when I do that, I get y is equal to 2 times 7 minus 10. So it tells me y is 14 minus 10, or just 4. So my ordered pair then for my point of concurrency here, we are seeing is in fact 7, 4, which is the orthocenter. Okay, every problem that they ask you for in regards to finding the orthocenter is that process. This is a great example to show you that the orthocenter can show up on the outside of the circle, or sorry, outside of the triangle, not circle. The next question, obviously the same procedure. Okay, this is the second question. Kind of going through the same process, but I think I'm going to, instead of jumping back and forth between the two programs, just going to do this all this work in GeoGebra. The first thing we're going to do is focus on point A, so that point there, and we're going to find the slope of BC, okay, the side opposite, okay, so I want to ask it to show me those 2 points. Okay, now all I have to do is find the slope between B and C. So if I find the slope between B and C, I'm going to go 4 minus -6. So 4 minus -6. Okay, and then I'm going to go 8 minus 4. So there's the slope of B to C, which is going to be, what, 10 over 4, which reduces to 5 over 2. Okay, so slope of B to C is 5 over 2, and then anything perpendicular to BC is going to be the opposite side reciprocal. So when I want to find this line from A perpendicular over here to BC, that slope should be -2/5. Okay, so the slope of that line, -2/5. But we also know that that line has the point 0, 2 on it. Okay, so I'm going to write my equation as y minus y1 is equal to -2/5 x minus x1. So that, when I evaluate that, becomes y equals -2/5 x plus 2.
Plus? What's plus mean?
So that's the equation then of that altitude. Okay, and then I'll just color that altitude so we talk about it later. Color it red. If we put in y equals mx plus b form, we see it. -2/5 is -0.4, and then we'll plus 2. So we get that equation, and then I'm just going to erase all this stuff, but remind myself that that equation was y equals -2/5 x plus 2. So that's one of my equations. Now we're going to do the exact same process. Let's start at B. Okay. And when I start at B, I'm going to go to segment AC. So I need to figure out what the slope of AC is. So we'll go 2 minus -6. So 2 minus -6 gives me 8. And then 0 minus 4 gives me -4. So my slope there is going to be -2. So then anything perpendicular to AC should have a slope of 1/2. So the line that I'm interested in, the line from B perpendicular to AC, should have, that line right there should have a slope of 1/2. Just double checking. If I click on that slope tool and then click on that line, it does give me that 0.5 right there, maybe better seen over here, of 1/2. So I know that that slope is 1/2, and I know on that line is the 0.84. So again, I'm going to go with y minus y1 being 4 equals slope of 1/2 now, x minus 8. And now I'm just going to distribute my 1/2, add 4 to both sides, so you get 1/2 x. Now that's a nice equation because there is no constant part like this plus 2 up here was the constant part for that equation. I just have my variable component. Okay, and anything that goes through 0, 0 would be a line that has just a y-intercept of 0. And we can verify this, put that in y equals mx plus b form, I get 1/2 x. So let's color that one blue. We'll talk about that later. So we now have the equation y equals 1/2 x. Okay, so that is actually enough for us to be done to come up with the location of this orthocenter, but I did ask you to go a little bit further and find that third equation, so we'll do that. So that was starting at point C, and then we'll go perpendicular to AB. Okay, so AB slope is what we need to find. So 4 minus 2 gives me 2, and then 8 minus 0 gives me 8. So that's a 1/4 ratio, and then anything perpendicular to that should be the opposite sign reciprocal, so it should be -4. So if I draw in this perpendicular line that I'm interested in, that one there should have a slope of -4. And it also goes through the point C. So I'm going to say y minus y1 is equal to a slope of -4 times x minus x1, which is 4. Okay? Remember, x1 and y1 are the point that I know is on my line. So I get y plus 6 is equal to -4x plus 16. I'll subtract 6 from both sides and get y equals -4x plus 10. If we look at this one here, put in y equals mx plus b form, we do see that we have that line -4x plus 10. Okay, and we'll make that one green. So now the idea is, algebraically, we should be able to find the location of those 3 points, or 3 lines. Sorry, my daughter thinks she needs to sing. So now we have these 3 equations, and we can use any 2 of them to come up with the intersection, which would be the orthocenter. So I'm just going to use, I think these 2, that one there, 1/2 x, and maybe this one are probably the easier ones to deal with. So we'll do that algebra here. We'll write, again, same as all the problems we've done. If the y's are the same, then the 1/2 x portion and then -4x plus 10 portion should be the same. I'm going to double everything so I get rid of fractions. I'm going to add 8x to both sides, and then we'll divide both sides by 9. So you're going to x coordinate to be 20/9. Okay, I'll talk about what that means here in a moment. But now we do have the ability to plug that 20/9 back into this equation up here to find my y. So, and you can plug back into any one of these equations. I just think it's probably easier to plug into this one. So when I do that, it says y equals half of whatever x was. Well, x was 20/9. Okay, that factor of 2 and the factor of 2 that's in there will cancel out. And I get 1 times 10, which is 10, and then 1 times 9, which is 9. So I get 10 ninths. So this ordered pair right there should be 20/9, or sorry, 20/9, comma 10/9. And if we ask it for the intersection point, obviously it's going to give it to me as a decimal, but 20/9 should be 2 2/9. 2 2/9 is 2.2 repeating. And then 10/9 should be 1 1/9, which is 1.1 repeating. So let's see if we get those. So I'll click the intersect tool. We're interested where those 2 lines there intersect, and it gives me 2.22 repeating, 1.11 repeating. So that is in fact the ordered pair that we're looking for. What I like about GeoGebra, you can see here. Obviously, I used the first 2 lines, but you can see that if you ask to do the algebra between G and H, these 2 lines, the red, or sorry, the blue one and the green one, click on those 2 for intersect. Okay, it still gives me the point 2.22, comma 1.11, and then maybe if I intersect the top one and the bottom one, still gives me the same exact point 2.22, comma 1.11, which just verifies that when we're doing the algebra by hand, when I chose the red and the green one, sorry, the red one and the blue one, when I chose those 2 or I guess I chose, I'm sorry, I've seen the 4 here. Well, I guess I did choose the blue one and the green one. When I chose those 2 and solved for x and y, it doesn't really matter. I'm going to get the same x and same y value as I would have gotten if I would have chose the red one with the green one, or if I would have chose the red one with the blue one. Okay, so that ordered pair then is 20/9, sorry, 20/9, comma 10/9, and I'd prefer that you keep it that way. With a lot of things that we do later on, this number here cannot be written in a very nice way as a decimal. For instance, if I round it out to 15 decimal places, At some stage, I got to cut it off. Okay, so well, 2.2 out to 15 decimal places is not the same thing as 29ths. It's very, very close, but it's not the same thing. 29ths is what we're looking for. Um, like I said, as in class, we're going to continue to work with this stuff. This creating of equations process is going to be one of the most important things that you guys take out of high school math. It just pervasive through all math courses and even into your science courses. I think it becomes something that's pretty useful to you. So we'll continue to work on this, but again, you're going to have to take the steps. If this is something you struggle with, take the steps to figure out where your gaps and misunderstanding are, and then address those.